Okay, so after this you have something as rules of differentiation. If you all write down differentiation, there you go. Okay, so rules are pretty simple. Let's say you are having two functions, f of x and g of x. Both are differentiable. If the function is not differentiable, then we will not speak of derivative. It does not make sense, because derivative does not make sense. If the function is not differentiable, then derivative will not make sense, because you will have two different derivatives. One is left side, one is right side. Then differentiation will not make sense, because you have two different numbers, no, left hand, right hand. So what is derivative? If I ask, you cannot tell me the answer, because you are having two different derivatives. One is left hand derivative. So when you are saying differentiability, when you are saying rules of differentiation, if you want to apply, both your function f and your function g, both of them are differentiable. That is, both, now for f, right hand left hand will be equal, the derivatives will be equal. For g also, right hand derivative, left hand derivative, they are equal. Both the functions are differentiable. I'll write over here, f and g are differentiable. Without them being differentiable, it does not make sense, because again for f I'll have left, right, two different derivatives. For g I'll have two different. So what is derivative of f? It does not make sense. Okay, so the first rule is, what is the differentiation of, or what is the derivative of addition of these two functions, f of x plus g of x? What is the, so f of x plus g of x, for example, f of x plus g of x can be a function called as h of x. So for example, you can have f of x is equals to x and g of x is equals to sine x. So what is your h of x? H of x is nothing but x plus sine x. So what is this rule telling? What is the differentiation of x plus sine x? Now what is the rule? Rule is pretty straightforward. You find the differentiation or the derivative of f, and then you find the derivative of g separately. So using this example, what is this? It is derivative of x plus derivative of sine x. Now this is dx, this just becomes 1. Now what is the derivative of sine? We just proved it is cos x. So that is your answer. So this will be your h dash of x, because h of x is your x plus sine x, right? So that is what derivative you have found. dh by dx, correct, is equals to 1 plus cos x. So pretty straightforward. Addition, whenever there is addition, it is just separated. Differentiate the first function plus differentiate the second function. You can also have multiple type, like what is the differentiation of f1 plus f2 plus f3 plus f4. All these are functions. So what you do, you just separately differentiate and add them. Differentiation of first, differentiation of second, plus differentiation of third, plus differentiation of fourth. Pretty straightforward. Second rule, differentiation of subtraction, that is f minus g. Again, this is same like addition. The understanding is same as addition. You just subtract them. Differentiation of first function minus differentiation of second function. Rule number third. Rule number third is multiplication of functions. When you have multiplication of functions, then it is a bit different. It is first function multiplied with differentiation of second function plus second function multiplied with differentiation of first function. If you want, I can give proof for this, and let's see the proof for this. So let's say your f of x multiplied with g of x. Let's say this is some function h of x. Okay, so I want to find the derivative of h of x. That is nothing but derivative of multiplication of f and g. So what does your derivative say? First principle, h of x plus h minus, okay, we are using h two times, so let's not use h. let's use something else. Let's say this is a. So a of x plus h minus a of x divided by h, and limit as h goes to 0. So that is nothing but, I'll continue down. So that is nothing but f of x plus h g of x plus h. You're finding the derivative of multiplication of two functions, na? F of x g of x divided by h. Now you have to do some trickery over here, because for addition of functions then it is very straightforward. It just splits up, differentiation of first plus differentiation of second plus differentiation of third. Now for multiplication, how do you separate it? How do you separate it as differentiation of first function, then differentiation of second function? So the trick is straightforward. What you do is f of x plus h g of x plus h, I will subtract f of x g of x plus h. Now since I have subtracted this extra quantity, I will also have to add it, otherwise my question will change. So because minus plus it becomes 0, because this whole thing is nothing but plus 0, na? Your answer is not going to change. Any number plus 0 is going to be the same number. Now what is this? Minus f of x g of x plus h, and this you're adding negative plus, it just becomes 0. Then finally I'm having minus f of x g of x, and the whole is divided with h. Now I will group the terms. I'll group these two terms and I'll group these two terms. Now from the first group, can I see that g of x plus h is common? I can clearly see that g of x plus h is common, and inside I'm having f of x plus h minus f of x. That is, I'm having inside the bracket. And then from the second grouping, I can say that f of x is common, and then inside the bracket I'm having g of x plus h and minus g of x. I have my limit, and all of this is divided with h. Now again I'll split this. This is my first term, this is my second term. So if I'm having something as a plus b divided by 2, that is nothing but a divided by 2 plus b divided by 2, no? So I can split it like that. The way I will split it is g of x plus h, f of x plus h minus f of x, this is divided with h, plus f of x g of x plus h minus g of x, and this is divided with h. I have my limit. Now can you see my limit as h goes to 0? What is this? And what is this? That is your derivative of f, right? And the second this is derivative of f dash, and this is derivative of g dash. This is derivative of g, right? Change in f, how much is your f changing, and here how much is your g changing, right? So I can much simplify this and write it as x plus h, this is your f dash of x, plus f of x, this is your g dash of x. Now what is g of x plus h, limit as h goes to 0? Now here is one important fact that you need to understand. Starting of the question, or starting of this, we noted that f and g are differentiable. F and g are differentiable. That is, differentiable means what? Left hand derivative, right hand derivative, everywhere they are equal. So when your left hand derivative and right hand derivative are equal, then they are differentiable. Now when they are differentiable, implies f and g are continuous. This is also an exercise that you need to find out, that differentiability implies continuity. This we have done in the class. But continuity need not imply differentiable. That function can be continuous, but it need not be differentiable. But when it is differentiable, that is why differentiation is a higher topic. It's a higher condition. When it is differentiable, then they are continuous. And when they are continuous, you know that what is continuous? Continuous means left hand limit, right hand limit and function, and they should be same, na? That is g of x plus h should be equal to g of x should be equal to g of x minus h. Here there is limit, h goes to 0, n goes to 0. So all these three are equal. That is the meaning of continuity, na? Differentiability means what? Right hand derivative, left hand derivative are equal. But continuity means what? These three things should be same at x, at whatever point you are checking. So now here limit as h goes to 0, g of x plus h. That is nothing but g of x, right? Because g is differentiable, that means that g is continuous. And then instead of g of x plus h, I can write it as g of x. So now this whole expression becomes g of x f dash of x plus f of x g dash of x. But what is this? This you can scroll up and check. This is nothing but differentiation of multiplication of function. So this is, I can rearrange this as g df dx plus f dg dx. That is the proof. So now if you want, you can try to prove the first two rules, that is addition of function and subtraction of function. Then this is multiplication of function. After this you have division of function. This is also a rule that, this is I think so the fourth rule. Yeah, third rule was multiplication, and the fourth rule is, okay, so for multiplication rule I have written f dg d plus. Now plus is commutative, right? You write a plus b or you write b plus a. Here I have written a plus b, but here I am writing b plus a. It is the same thing. Understand, the concept is the same thing. You write 2 plus 3 or you write 3 plus 2, you are going to get 5 only. That property is called as commutative. That also we have discussed in class. Now what about division? Division is simple. Not as simple, but the proof is simple. Proof is left as an exercise for you. This is going to be this minus g times differentiation of x divided by g square. So this formula you also prove it as an exercise. So we will be using these rules. This is the fourth rule that we studied. We will be using these rules to solve problems. So let's take down some problems. So for example, first problem we'll use the addition rule. We can have cos x plus e raised to x. Now what is differentiation of f? It is going to be differentiation of cos x plus e raised to x. So this is, what is this? Addition rule says that the differentiation splits up. The addition will split up, no? That is the addition rule. Now what is differentiation of cos? It is minus sign. Differentiation of e raised to x is e raised to x. Now this, I told you, derivatives of special functions. I have written that over here. Yeah. So we need to use this. Derivatives of special functions. That is an important thing that everyone should know. So that's it. So this is derivative of f. Now we can have f of x is equals to, let's say, x into root x. We can use multiplication of functions. But we can again see, instead of using multiplication, that is x is your first function, this is your second function. So what is df dx? This is going to be x differentiation of root x plus root x differentiation of x. That is the multiplication rule, na? Rule number 3. Rule number 3 is what we are using. So what is this? X differentiation. What is root x? Root x is nothing but x raised to half plus root x. This dx and dx get cancelled, so this is just root x. Now what is the power rule? Power rule is this, what we wrote down previously. Power rule says that the power comes down and power of x becomes 1 less, that is n minus 1. So what is this? 1 by 2 is brought down and x is raised to 1 by 2 minus 1, this plus root x. So this is the rule that we are using. So what is this? 1 by 2 multiplied with x multiplied with 1 by 2 minus 1 is minus 1 by 2, but x is nothing but this is 1 plus root x. Now what we can use? Exponent properties. X raised to 1 multiplied with x raised to minus 1 by 2, so that is nothing but x raised to 1 minus 1 by 2 plus root x. So 1 minus 1 by 2 is nothing but again 1 by 2, so that is nothing but root x by 2 plus root x. I'll multiply both denominator and numerator with 2, only then I can add the numerators. So this is 3 root x divided by 2, correct? So my differentiation of f of x, that is the derivative of f of x, derivative of f of x is this. So just use the rules, multiplication rule, addition rule. We can also try one example with division rule. We can have something as, for example, sin x divided with e raised to x. So what does your division rule say? Division rule is f times dg dx minus g times df dx divided by g square. So what is f? This is the rule, right? Wait, let's say this is your h, because f is being repeated everywhere. Okay, so this is your h. So here f means your first numerator function, that is your sin x. So here f of x means your numerator function, which is sin x, and g of x means your denominator function, which is e raised to x. So when you're having division of functions, that is sin x is your first function, e raised to x is your second function, but they are divided. So when you have division, how will you find the derivative? You will use this formula. So f is your sin x multiplied with dg dx. dg dx means derivative of e raised to x. Derivative of e raised to x is e raised to x minus g. What is g again? G is e raised to x. Derivative of f of x. This is the derivative of f. What is f? F is sin x. So derivative of sin is cos divided by g square, which is e raised to x squared. I'll just simplify this expression. It becomes e raised to x common outside, sin x minus cos x divided by e raised to x squared. So this 1 e raised to x I can cancel, because in denominator I'm having 2 e raised to x. Now e raised to x square means what? E raised to x squared just means that e raised to x 2 times multiplied, na? So 1 I can cancel. So the answer is sin x minus cos x divided by e raised to x. So that is your derivative of h of x. Question is h of x. So h of x is equals to sin x divided by e raised to x. So what is the derivative of h? Derivative of h is sin x minus cos x divided by e raised to x. Then you can have another simple example. Let's say k of x is equals to x raised to 5 tan x. Now what is the derivative? Here again you will use product rule, multiplication rule, rule number 3 I think. X raised to 5 is first function, tan x is second function. So derivative of this is going to be derivative of x raised to 5 tan x. That is nothing but what is the rule? Rule is x raised to 5 derivative of second plus second function multiplied with derivative of first function. So what is derivative of tan? Derivative of tan is sec square plus tan x. Now here you will use power rule. 5 comes down, 1 power becomes less. So that is the final answer. Put the brackets properly. Here 5x raised to 4 is multiplied with tan x. It is not multiplied with this x. It is multiplied with tan x. Okay. So now those are all the rules. So 4 rules that you studied: addition, subtraction, multiplication, division. Now the next rule that you will study is composition rule. Composition means that the input of one function, input of f, is output of the other function. So how to find derivative of this? Now what does this expression say? That change in x, when there is change in x, your x is your input. But what is the input of f? Input of f is g, right? So when your x is changing from x to x plus h, your g will change from g of x to g of x plus h, and then your f will change. F will not directly change, no? F cannot directly change. F cannot directly change. Your x will change, then your g will change, and then your f will change. So can I directly find the derivative of f with respect to x? I cannot find a derivative of f directly with respect to x, no? Because x is first affecting g and then you are getting f. So how the rule says that, this is your rule number 5. So here the rule says that this is nothing but derivative of f with respect to its own input multiplied by derivative of g with respect to its input. So in other terms, you can, another notation you can have derivative of this f dash. This is nothing but let's not say f dash, let's say, I'll just write this notation. This is f dash with respect to g, and then you have g dash with respect to x. Let's take an example that will be much simple to understand. Let's take an example, because when I'm saying f dash over here, that is derivative of f with respect to this, with respect to its input. This and this are same, because dash means with respect to its own input. Input of f. What is input of f? Input of f is g. So derivative of f with respect to, so those two boxed terms, they are same. These two terms are same. Now this term and this term are same. They both are same. So let's take an example. Let's say find the derivative of sine of x raised to 5. Now can you say inside sine there is one more function? Now keep on, now how do you read? You read from left to right, correct? So first thing that you read is sine. Now what is differentiation of sine? Derivative of sine. Derivative of sine is cos. Now can I say cos x? No, I cannot say cos x, right? Because it is derivative of sine of x raised to 5. So this will be cos of x raised to 5. Now can I stop here? No, I cannot stop, because I have to find the derivative of x raised to 5 multiplied by derivative of x raised to 5. That is 5 times x raised to 4, power rule. So keep on differentiating what is inside. So that is the answer. We can have one more example. What is the derivative of sine x? What is derivative of this? First you will read this sine. This will be your first. So derivative of that sine is cos. But what is the input of that sine? Input is sine x. Now can I stop here? I cannot stop here. I have to continue. Multiplied by derivative of this. Derivative of sine x. Now derivative of sine x is cos x. That is the answer. We can have one more example, differentiation of sine of log x. Now keep in mind all these examples, one function is inside one more function. Okay, the functions are not multiplied, they are not add, there is no addition, there is no multiplication, there is no subtraction, there is no division. This is rule number 5. This rule is completely different. Here one function is inside another function. So here what is, now again read from here, sine. What is differentiation of sine? Derivative of sine is cos. Input, what is the input? Log x multiplied by, what is the derivative of log? 1 by x. That's it. Now you can have something like this also, sine of log of cos x. Okay, what is the derivative of this? First you will read sine, correct? So what is the derivative of sine? Cos. What is the input? But input is log of cos x multiplied by, what is the derivative of log? 1 divide log, what it does, whatever is inside brings it down. What is inside? Cos x. Now derivative of cos x. Derivative of cos x is minus sin x. That's it. That's the answer. So the way you read, that's the way you go on finding the derivative. So derivative of sine is cos, derivative of log is 1 divided by, then derivative of finally cos is minus sine. But make sure you put the input properly. I cannot say derivative of sine, then I'll just write sin x. No, it is not sin x. It is sine of derivative of sine. I cannot just write cos x. I cannot write derivative of sine. What is the derivative of sine? I cannot just write cos x. No, I should write derivative of sine of all this. So derivative of sine of that is sine of cos of log cos x. The inputs, you should be careful with the input of the function. Okay, we'll take a few more examples. Let's say find the derivative of sine of e raised to x multiplied by e raised to x. Now here first you will see the multiplication rule. Two functions are being multiplied. So that is nothing but first function. Now what is the rule? The rule number 3. First function multiplied with derivative of second function plus second function multiplied with derivative of first function. That is the rule, multiplication rule. So that is equal to sine of e raised to x. What is derivative of e raised to x? It is e raised to x plus e raised to x. Now what is this? What is derivative of sine? Derivative of sine is cos. But inside I will not write ex because input, what is input of sine? It is e raised to x. Can I stop here? No, I have to find derivative of this also, e raised to x multiplied by, what is derivative of e raised to x? E raised to x. So your final answer will be, I'll take out e raised to x common. Inside I'll have sine of e raised to x plus e raised to x cos of e raised to x. So this is the final answer. So first you have seen that two functions are multiplied, then you will split it, and after splitting you are seeing that sine function, there is composition, because inside sine function there is e raised to x. So then you just go on differentiating it. So this box I'll try, this and this box, they both are same. So differentiation of sine is cos, but I cannot write cos x because input of sine is e raised to x. So it is cos of e raised to x multiplied by, there is one more function inside, e raised to x. What is differentiation of e raised to x? E raised to x. So that is why these two boxes are same. I can give one more exercise. As an exercise you can take down this example, log of tan x multiplied by 6 square x. Find the differentiation or the derivative of this function. First you notice that two functions are multiplied, then you use rule number 3. Use rule number 3. After using rule number 3, you have to be careful, because when you are differentiating log of tan x, one function is inside the other function. So use that properly. So this is an exercise. And what about f of x is equals to sine x square? How will you find the derivative of this? What is derivative of this? The first thing that you see, it is squared, no? It is sine x squared. So first you will be using power rule, because inside the power rule sine x is there. So first it is squared, right? You can also use multiplication rule if you want. You can see it is sine x multiplied by sine x, and then you can try to use rule number 3, that is multiplication rule. But I can also use power rule here. What is power rule? Power rule says that the power comes down and the power becomes 1 less. So 2 minus 1 is 1. I cannot stop here, because first I have used power rule of power function, but now I'm also having sine x function. What is the differentiation of sine? Derivative of sine is cos x. So this is my answer. And if I want to use multiplication rule, that is sine x multiplied by sine x. If I want to use multiplication rule, I'll have something like this: sine x differentiation of second function plus first function, second function multiplied with differentiation of first function. So what is this? This is just sine x cos x plus sine x cos x, and that is nothing but 2 sine x cos x. That's same. Answers we will get are same. You use any rule you want, answer you will get is same. And 2 sin x cos x is nothing but sin 2x. Trigonometric properties, everyone should know. After this, what did we study? After this, we had something called as log differentiation, logarithmic differentiation. Logarithmic